In this example, we are going to apply the 5 rules that we learned about sketching for root locus. So we start from the first rule about the number of poles. So I mean the number of branches. So the number of branches is equal to number of poles. So we have here 4 poles, one at s equal to 0, one at s equal to -1, one at equal to -2, one at s equal to -4, and we have one 0 at s equal to -3. Okay, so number of poles equal to 4, number of zeros equal to 1 only, while number of zeros at infinity is equal to 3. We have 3 zeros at infinity, we have one finite zero at -3, and we have 4 poles. So the first rule here, number of branches for root locus is equal to number of poles. So we will have 4 branches for root locus. Okay. The second rule we need to know, which is related to the start point and end point of the root locus. Usually the root locus will start at the pole and end at the zeros. Okay, since we have 4 poles, that means we have 4 root locus will start at the 4 uh, poles points. So if we have the s-plane representation here, so the first pole is at s equal to 0, the second pole is at s equal to -1, the third pole is at s equal to -2, the third pole will be at s equal to -4. So this is -4, -2, -1, and 0, and we have here 0 at -3 according to the 0 here, to the numerator of the transfer function. Okay, so if we want to apply the second rule, and the second rule said is the existence of root locus on the real axis. So if we want to represent here, so if we are in the left of odd number of poles or zeros, so there is root locus. So in this area on the right real axis, there is no roots, no poles, no zeros, so there is no root locus. Here on the left of 0, we are on the left of one root, or on the left of one pole, so we have root locus in this area. Between -1 and -2, there is no poles. I mean, there is no root locus here, because we are on the left of 2 poles, so there is no here. On the left of 2, we are on the left of 3 poles, so there will be a root locus here. On the left of -3 here, we do not have any root locus, because we are on the left of 3 poles plus 1 0, so it's even number, it's not odd number. So at this point there is no root locus between 3 and 4. And on the right or on the left of the last pole, which is -4 here, we will be on the left of 1 2 3 4 5. So 5 is odd number, so at this point we will have a root locus. So here we have a root locus. So these are the 3 main segments of root locus on real axis. Yes, we have 4 root locus, but not all placed on the real axis. We will see them. We will see how to draw the 4 segment. We said we have 4 root locus. Here on the real axis we have only 3, but when we when we finish applying the rule, we are going to see the 4 segment of the root locus. We said root locus start at the pole point and end at the 0. So we need to highlight the direction of the root locus here. So for example, for this point here, for the third segment of root locus, it starts at pole. That means it will start at -4. So the direction will be in this area or in this direction. So start at -4 and go with the axis here. Then the second will be start at -2 and go to the 0, which is -3. So this one is complete. This is a complete segment of root locus here. Will be drawn between -2 and -3, because it starts at the pole and at 0. Nothing need to be changed here. But between 0 and -1, we have a root locus, but it will start from the 0 but not end at -1, because -1 also is a pool. So there is another one, we start from -1 also to this direction. So we have two pools here, start, but we don't know where to stop. Okay, we start from 0, we go to um, the first 0, then we start at -1, we go to the second 0. We said we have three zeros at infinity, so that means we will have three asymptotes according to the rule number 5. So for now we apply the first rule of branches, the second rule for the, I mean the place of, I mean the third rule, which is the place of the root locus on the real axis. For symmetry here, it will not be clear unless we finish the drawing of the root locus. For this one now symmetry, because we don't draw the on this part, so we cannot see the root locus on that part. So we just postpone the applicable application of rule number 2, which is regarding the symmetry. We move to the asymptote here and the centroid point. In order to find the centroid point, and the centroid point is the point where we draw uh, the asymptote, or the intersection of asymptote with the real axis. So this we call it the centroid point. Centroid point is the point where the asymptote are close to the are connected to the real axis. So how to find the centroid point? We said it's summation of real part of poles, real of poles minus summation of real part of zeros over number of pole minus number of zeros. So if we want to find the value of sigma here, or the centroid point, we need to apply the formula. So centroid will equal to summation of real part of pools. So we have four pools. If we add, all are real, so if we add them, so we have -1, -2, -4, so the total is -7. Okay, summation of this real part is will be -7 minus the summation of real part of 0. We only have one 0 and it is real, and it's located at -3, so it will be -3 or +3. Okay, over the number of poles, which is 4, minus number of 0, which is 1. Okay, as a count, as a number. Okay, so this is -7 plus 3, we have -4 over 3. So the centroid point will be placed on -4 over 3. That means it's like 1/3. Okay, but negative, so it will be here in this area. The centroid point will be located in this point. So the centroid will be placed in this area. So this is -4 over 3. Okay, so from this centroid point, we are going to draw our asymptote. Okay, and the asymptote that we are going to draw, how many asymptotes do we have? Number of asymptotes equal to the number of 0 at infinity, so it will be 3. We have 3 asymptotes. Since we have 3 asymptotes, that means we are going to draw through our 3 dashed lines, okay, which will guide the root locus to go to the infinity. So where we are, or what is the angle for this asymptote? It depends on the rule number 5, or will be calculated from rule number 5. We said 1 plus 2k times pi. So the first asymptote will have k equal to 0, so it will be at I mean 2k, 1 plus 2k over plus pi over mb minus n 0. As we see here, this is the angle of asymptote here. This is the formula. So the angle of asymptote equal to pi times 1 plus 2k over mb minus n 0. So in our case here, we just remove this one. Okay, so in our case, if I want to find the angle of asymptote, which is phi here, we should have phi1, phi2, phi3. Since we have 3 asymptote, so we should have 3 angles. So phi1 will be equal to 2k plus 1 times pi over number of poles, which is 4, minus number of zeros, which is 1. So it will be like 2k plus 1 when k equal to 0, the first value of k. So it will be pi over 4 minus 1, which will be 3. The second will be also 2k plus 1 pi over 3. So the k equal to 1, so it will be 2 times 1, it will be 2 plus 1, so it will be 3 pi over 3. So it will give you the value is equal to pi. The third angle will be 2 times 2, so k equal to 2 here, plus 1, so it will be 5 by over 3. So it will be equal to negative, equal to 5 by over 3, or equal to negative pi over 3, as we already mentioned before. So the asymptote that we are going to draw at this point, which is the negative 4 over 3, the centroid point. Centroid point is equal to negative 4 over 3. So if we just have this drawing, so at the point of centroid here, which is negative 4 over 3, we will have 3 asymptote, one with angle of 60, one with angle of negative 60, and one with angle of 180, which will go with the real axis. So this is how we can draw the asymptote. After we draw the asymptote, it will be clear how this, I mean the poles of 0 and the pole of negative 1 will, how we can draw the root locus from the pole 0 and from pole 1 to go to the infinity value. Okay, so you can see here, after we find the value of the angle for all, I mean, which is the angle of asymptote, and this is the centroid point, which is negative 4 over 3 that we already mentioned before, and the angles will be like pi over 3, pi, and 5 pi over 3, which is negative pi over 6. So you can see here how the drawing will be like. So this is the zero number one, I mean the first pole at 0, the second pole at negative 1. As we said, the direction, as you can see here, the direction, the pole, I mean the root locus start from the pole, will not go to the other pole. No, it must go to the 0. So start from this point, go here, then either it will go to the 0 at infinity from this line in parallel with the asymptote. This is the asymptote value, this is the asymptote line, this is another asymptote line, and here we have also one asymptote which is in with imaginary, I mean with real axis. Okay, so we have 3 asymptotes. So the first asymptote here will guide the root locus which go from 0 or from negative 1. The second will guide the root locus which come from 0 or negative 1. So these two asymptotes are responsible to guide or to provide the path for the root locus from the first pole and the second pole. This is first pole at 0, the second pole at negative 1. So if it starts from 0, if we just make highlight, for example, the first pole here, okay, so the first pole or the first root locus will start from 0, either go to infinity through this line. So this will be the direction of root locus or the segment of root locus. We said we have 4 segments of root locus. For segment, this is the first segment already there. We mentioned, we said this no change. Start from the pole, end at 0, no more change. So this is one segment. Okay. So the second segment here will be start from 0, go to infinity through this line in parallel with this asymptote. Okay. Then the third segment will go through the second one here, start from negative 1, this line, and go to infinity. Why go to infinity? Because we said it should start from the pole, end at 0. Since we have only one 0 here, so the rest of zeros are at infinity. So this root locus will start from this pole and go to infinity to catch up the 0 that we have at infinity. Okay, so this is good for example, if we say this one is z1, okay, that means z1 is at negative 3, but z2, as we mentioned before, is at infinity, z3 at infinity, z4 at infinity. Okay, So the first here, the pole -2 go to Z1. So Z1 is okay. Now no more, because we already draw the root locus for Z1 between this pole and Z1. We said this one is P1, this is B2, for example, this is B3, this is B4. Okay. Now we said each root locus start at a pole and end at 0. So P1, for example, here, or P3, based on this figure, will be connected to Z1. Okay, so this is the first root locus that we draw on the real axis, and we say this already finished or complete. No need to do anything. Okay, the second pole, or the second root locus, will start from pole number 1, which is here, and will go through this yellow light. I mean yellow highlight. So it will go to any of these zeros. So we let us say this will go to zero number 2. Zero number 2 is existing at infinity, but in this direction. Okay, so the third root locus here will be start from the point which is P2. So it start at P2 and should end at Z3, for example. So the Z3 will be in this direction. So here goes to Z3, connect to the Z3. Okay, so start at pool, end at 0. Start at pool, end at 0. Okay, the third or the last pool here, which is B4, because B3 already covered here, so B4 is here. So B4 will go to infinity also. Why go to infinity? Because we said we have 3 asymptotes. So these 2 asymptotes go to infinity, already guide the root locus from B1 and the root locus from B2. The third asymptote will guide the root locus come from the, and we already know this one, this root locus we draw because it's a part of the real segment. So we said it is go to infinity here, and the asymptote, it has the angle of pi, so it will go here. But here this asymptote angle is pi over 3. Here this asymptote is pi over 3 negative. Okay, so now the last one, which is B4, will go for to Z4 at, or this one at infinity, at infinity, at infinity here, to Z1 at -3. Okay, so this is how we can draw the first form, or the general form of the root locus. You can see here, actually it's not compulsory that mean P1 will go to Z2. It can also B1 go to Z3. So that means the root locus will be, in this case, will be like this one. So I mean, instead of going from, uh, for example, if we use the other color, we can start from this one, which is 0, and go to infinity from this line. And that one is start from 0 and I mean -1 and go to infinity to this way. So it is the same, but we are looking here, I mean go to this way. So you can see now, if we want to apply the form of or the rule number 2, we said the root locus should be symmetry around the real axis. So this is the real axis here, and you can see here the root locus is symmetry. This part is the same as that part, so it's like a mirror here with respect to the real axis. Okay, so this is the symmetry rule. So now if we say that, we see the, if we want to just to go through the 5 rules that we have, the first rule is branches. So the number of branches here is equal to the number of segment for root locus is equal to the number of poles. So this is, if we say this is number 1, go here to infinity, for example. This is number 2, this is a segment, go there to infinity, 2 segment, 3 segment, 4 segments. So this is the rule number 1. We have 4 segments or 4 branches. Okay, the rule number 2 is symmetry. So we can see here, this part is symmetrical with that part. Symmetry around the real axis. If it's already on the real axis, no, don't log for symmetry because it's already on the real axis. The symmetry means if you have a part on top, you have a part on the bottom. If you have part in Q4 and in Q3, you have a part in Q4. If you have a part in Q1, you should have a part in Q2. Okay, so it's also symmetry here. So this is the symmetrical form of, or rule number 2. The rule number 3 is the segment of root locus on the real axis. So we have actually three segment for root locus in real axis, and this segment actually, as we can see here, so the segment on the root locus is, this is the first segment from this point to that point. This is the first segment on the left of odd number, which is 0 here, only one bull. Only one bull. So one bull is odd. So we are on the left on the one bull. So we have a segment here. This is one segment. In this area, there is no root locus because we are not on the bull of, I mean, on the right, on the left of odd number, because we have one bull, we have one bull. So we have two bulls. So 2 is even number. At this area, we are on the left of three bulls, which is 0, -1, -2. So it is three bulls. So there will be a root locus in this area. So it's represented here. Then the last here we do not have because we are on the left of 1, 2, 3, 4. We are on the left of 4 bulls and 0. So there is no root locus in this area. Then at this point, we are on the left of 5 points or 5 zeros and bulls. So 1, 2, 3, 4, 5. So there will be a root locus here. So this is the rule number 2. I mean rule number 3. The rule number 4 is about centroid, and we said the centroid here represent the point that we are going to draw the root locus, which is negative. I mean the asymptote, which is -4/3 or 1 and third, -1 and third. So it will be placed in this area. So this is the centroid point or the sigma point. Then this is at this point we find the value of asymptote here, which cross with the real axis. Then the number of asymptote, which equal to number of poles minus number of zeros. So we have poles are 4, zeros is 1. So we have only 3 asymptotes. So this is one asymptote. This is second asymptote. The third asymptote is placed on the real axis. So we have 3 asymptotes. The angle of asymptote, which is the rule number 5, it can be found by applying the formula which said 2k plus 1 by over mb minus nz. Okay, so we apply this formula, we find the angle of asymptote is pi over 3 pi and negative pi over 3, which is -60. So this is the angle of first asymptote, this is the angle of second asymptote, and the angle of the third asymptote is 180, which is irreal. So by applying these 5 rules, we achieved or we can draw this root locus. So the blue color in this figure represent our root locus. The black lines here represent the asymptotes, and the cross represent the pole. The hole represent, or the circle represent the zeros. Okay, I think this I hope this is clear now. So the next example, we are going to repeat the same steps. I mean, we are going to apply the same rules in order to draw the general form of root locus. Actually, there are some parts we don't know actually in this figure here. If we see here, there are some parts we need to know more. I mean, it's not clear or not specific. So as you can see here, if I ask you now, what is this point? The cross with the real axis, it's not there. We don't know what is the value here. Okay. If I ask you now, what is the point here? What is the number here? Is it 0.5, 0.4, 0.7? Also, we don't know. Okay. So also, if we ask what is the, I mean, if what is the situation if we have complex poles that is based in this area or in that area, how we are going to draw. So these things is more related to the 3 more rules, which is rule number 6, rule number 7, rule number 8. We are going to learn later on. Okay. So for now, we only apply 5 rules. So we are going to apply the 5 rules again on this figure or on this transfer function. So the transfer function here consists from no zeros, number of zeros equal to 0, number of poles equal to 3. Okay. If we have number of poles equal to 3, that means we have 3 segments of or 3 branches for root locus. Okay. So we have 3 branches based on the rule number 1. Then these branches should be symmetry should have symmetry around the real axis. So if you have on the top, you have on the bottom. Okay. Then the rule number 3 said the number of poles on the real axis or the root locus will be exist on the real axis only if it's on the left of odd number of poles or zeros. This will be we are going to see later on the next slide. Then we need to find the since we have the number of poles is not equal to number of zeros, so we should have centroid or we should have asymptote. Okay, so the number of asymptote here equal to mb minus nz, so equal to 3 because we have 3 minus 0 equal to 3, so we have 3 asymptotes. The angle of asymptote will be also 3 based on the value of k equal to 0, k equal to 1, k equal to 2. So we are going to have 3 angles which is the same like the previous angles. Since we have 3, so it should be like pi over, I mean, depends on the value of real number and imagine real part of the zeros and real part of the pools. Okay, so as we can see here, if you want to find the centroid point or the point of intersection between the asymptote and the real axis, so it will be summation of poles minus summation of zeros. Zero, we do not have any zeros here, but poles we have 3, so it will be negative. This the first pole is negative 2, the second pole is negative 4, the third pole is negative 6. So we have negative 2, negative 4, negative 6. The summation of them, it will be negative 12. Okay, so negative 12 here divided over number of poles, number of zeros, number of zeros 0, number of poles 3, so it will be negative 12 over 3, it will be negative 4. So the asymptote point here, or the asymptote intersection point with the real axis, will be at negative 4, as we will see later on. The angles here, the same as we said, is 60, 180 and negative 60, as you can see here. So this is the drawing here. The first zero here is I mean the first pole is placed at this point, the second pole is placed at that point, the third pole is placed at that point. We do not have any zeros, so no circle. We cannot see any circle here because we do not have a 0. Okay, so usually the root locus start at the 0, I mean at the pole, and end as 0. And we have a centroid point. The centroid point here is placed at negative 4. So this is negative 4. So here it is the centroid point. Since it is centroid point and also at the same time it is the pole point, because the pole here also at negative 4. Okay, so the centroid point at negative 4, the pole point at negative 4. So both are represented here as the same point. So from this point we are going to draw our asymptote. This is asymptote number 1. This is asymptote number 2. This is asymptote number 3. Will have angle of real axis of 180. Okay, same real axis. Okay, now when we apply the form of start point and end point, so the root locus will start at the pole, end as 0. So if we have P1 here, we said B1, P2, P3. So B1 is start at, as you see here, B1 is negative 2, negative 4, negative 6. Okay, so B1 is start at, the first one will start at negative 2, this one start negative 4, that one start at negative 6. Okay, so this is the start point. B1 go to where? Go to infinity, because we do not have any 0. This one also go to infinity, this one is go to infinity. Okay, this go to infinity with the asymptote number 1, this go to infinity asymptote number 2, this go to infinity with the asymptote number 3. Okay, so the asymptote number 1 here, that means we start from this pole, go there, then go to infinity. Start at this pole, go there, then go to infinity. Start at that pole, go to infinity. Okay, so this is how our root locus will looks like. So we have 3 root locus here, 3 root locus segment, because we have 3 poles, and this 3 root locus segment actually start from the pole end as 0. So if we highlight here, so the root locus start from the pole. This is the first one. Go to 0, either up or down. It depends. I mean, it's not compulsory to know where to go, but it should follow one of these lines, either up or down. So the second one, or the second root locus here, For example, to start from this pole, go to infinity also with the other asymptote. The third segment of root locus, says we have three poles, that means we have three segments. The third segment of root locus here is go here, start from this pole, go to infinity. So these are the three segments of our root locus. Three segment of our root locus, and the three segment of our root locus start at the poles and at the zeros at infinity. Here the zeros at infinity. We have also two lines for the, I mean three lines for asymptote, and this line for asymptote, actually this is one, and this line of the asymptote here, the first asymptote, this is the second asymptote, and the third asymptote is the one with the angle of 180. Okay, this actually all regarding the application of the five rules that we learned. And in the next video we are going to continue with the rest of the rules, which is rule number 6, rule number 7, and rule number 8. At the end we are going to reapply the 8 rules on one transfer function in order to draw the refining sketch of the root locus for this transfer function.